All right, this is the second lesson for the day. This is called Polynomial Identities. Now, a lot of these things we've already covered. We've already covered difference of squares. We've covered perfect square trinomials. There's two of them here. A plus b squared. Remember our square, double the pair. You square the a, you square the b, you double the pair. This one just has a minus, that one has a plus. These are the two new factoring methods that we're going to learn today. Sum and difference of cubes. Okay, these are perfect cubes, both of them. One's a sum, one's a difference. And you'll notice that basically the first set of parentheses is just the square root, or the cubed root of each term. I'm going to write down some perfect cubes in a minute. Cubed root of a cubed is a, cubed root of b cubed is b. And then notice, after we get that first set of parentheses, we square the first term, change the sign of the original. Both of these are changed. This is a plus, this is a minus, this is a minus, this is a plus, and I'll give you something that'll help you remember that in a second. And instead of doubling the pair, we just take the pair, a times b, and the last term's b squared. But how do you remember these signs? When you're dealing with a sum or difference of cubes, remember SOAP. Now what that stands for is the first sign is the same, the second sign is opposite, and the last sign is always positive. So same, opposite, always positive. Same, opposite, always positive. Okay, that just refers to the sign. Minus is the same, plus is the same. This sign here is the opposite of the first set of parentheses, or the original, and the last sign is always positive. All right, so let's take a look at a couple examples, things that we've already done. This is a difference of squares. I wrote down some perfect squares down here. If you want to pause and write those down, you can. These are the perfect squares. I can't list them all. These are the perfect cubes. What is a cube? This one is 1 times 1 times 1. This is 2 times 2 times 2, 3 times 3 times 3, and so on. If you remember those, that sure will help and save a lot of time on your work. So try and learn those. It's easy to write down. You can figure those out. So this one's a difference of squares. Notice we just took the square root of the first term. It goes in the first spot. Square root of the second term in the second spot. One's a plus, one's a minus. We've done many of those this year. This is a perfect square trinomial. Square root of x is x squared is x. Square root of 9 is 3. If you take this pair, 3 times x and double it, you get 6x. It's a perfect square trinomial, and so is this one. Perfect square. Take the square root of the first term, take the square root of the last term, and a check, multiply these together, and double it, and make sure you get that middle term. Right now for this one's a difference of cubes, this one's a sum of cubes. You'll notice 27 and 8 are on the list. Where is 27? It's the third one. The cubed root of 27x cubed is 3x. The cubed root of 8 is 2. It's the second one on the list. Same sign. Okay, then you square this term. 3x times 3x is 9x squared. Remember SOAP. Same, opposite, always positive. Multiply these two together. If you multiply these together, you get 6x, and that's the next term. We don't double that. And then we square the negative 2, and it's always positive, so it's positive 4. All right, cubed root of 64, find 64 on the list. It's the fourth one. The cubed root of 64 is 4. Cubed root of x cubed is x. 125 is the fifth number on the list. 1, 2, 3, 4, 5. The cubed root of 125 is 5. Same sign. Opposite sign, always positive. Square 4x, you get 16x squared. The pair is 20xy. You do not double it on this one. Okay, 20xy. change the sign. Same opposite, always positive. Square the 5y. All right, so let's try a couple here. And I have some on the other side. You should have printed this out, I hope. These are the notes. All right, so I see a minus, so this could be a difference of cubes or a difference of squares. And I see 49 and 81 on my list of perfect squares. This is a difference of squares. So I'm going to take the square root of these two terms. So a is going to be 7y to the third by taking the square root. Square root of 81 is 9. The square root of x to the fourth is x squared. Very simple when you take a square root when you're dealing with exponents. You just take half. Okay, so in a difference of squares, it's a minus b times a plus b. So this one would factor into this form right here. That's a difference of squares. Again, we've done many of those in this class. Now, 27 and 8, I see right here on this list of perfect cubes. This is a difference of cubes. So you take the cubed root of each of these terms. 27 is the third one on the list, so the cubed root of 27 is 3. The cubed root of y to the 6th, you just divide the exponent by 3. Over here we divided by 2 because there's a square root. Divide the exponent by 3, so it'd be 3y squared is my a term. 8 is the second one on the list, so that would be 2z to the first. All right, now in your first set of parentheses on a difference of cubes, you just write these two terms in with that sign in between. So 3y squared minus 2z. And that's where we get the same sign. Okay, then we take this term right here, and you'll notice up here on this right here is just saying take that first term and square it. So if I square 3y squared, I'll get 9y to the fourth. Don't forget your SOAP. Same, opposite, always positive. There's the same opposite sign. And then according to this rule here, you just take these two terms in here and multiply them together, a times b. So 3 times 2 would be 6, y to the second z. Always positive. And then the last term, you just square the b. So here's my b, 2z, square it, I get 4z squared. And that would be the factored form of this difference of cubes. This one is not a sum of cubes, it's not a difference of cubes, it's not a difference of squares, but I do notice this is a perfect square. Remember, you just divide your exponent by 2 and you take the square root. This is a perfect square, so it'd be 5b to the third. So maybe this is a perfect square trinomial. I'm going to try that. And my test then is to see if I multiply these two together and double it, do I get that? 8 times 5 is 40, doubled is 80. Yes, that does work. So there's my perfect square trinomial. All right, on the other side, these are also notes, it's not homework, but I'm going to show you how quick you can do these. This is a sum of cubes, and we have the rule right up here, sum of cubes. Basically, we take the square root. But if you just look at the signs, remember SOAP, same, opposite, always positive. That will eliminate this one because that's not positive. It eliminates this one because that minus is not the same as that. And then this one can't be because that's not the opposite. So that has to be the answer. And it is. The square root of x cubed is x. The square root of 8 is 2. And I'd like you to pause and see if you can answer the first 8 quickly. All right, back to these. I see this minus, so this is out. I see this is a minus, so this is out because that last one has to be positive. And then these two have to be opposite, so that's out. Okay, so positive, out, out. Opposite signs, that's not opposite, out. Here, don't switch the numbers, don't switch the order of the numbers. Has to be the same, so out. Okay, they both have to be a minus, that's out. And then these two have to be opposite, that one's out. Here, look how quick we can do these problems if you understand what we just did. Minus first, out, out. Signs have to be opposite. That's not the opposite of that minus. That's out. Here has to be a minus. Those two are out. The signs have to be opposite. This one's out. Okay, it has to start with a minus. This one's out. This one's out. The signs have to be opposite. These aren't opposite. That one's out. This has to start with a plus. Out. Has to always be positive here at the end, out. Has to be opposite here, same opposite, always positive, out. This one, A is X, B is 3, because 27 is the cubed root of 3. Or the cubed root of 27 is 3, sorry. So my first set of parentheses, same sign. And if you want, you can put the sign same, opposite, always positive. And then I just square that term. I multiply these two together. And I square that term. How easy are these? Yeah, they're pretty easy. All right, the cubed root of 8 is 2. Cubed root of x to the third is x. 125, the cubed root of that is 5. The first set of parentheses, a plus b, same, opposite, always positive. Square this first term. 2x times 2x is 4x squared. 2x times 5 is 10x. Again, we don't double that. 5 squared is 25. All right, so those are the notes. I'm going to do one problem from each side here. I'll try this one right here. I'm not going to tell you what kind they are. You got to figure it out. 25 and 49 are perfect squares. The square root of 25 is 5. Divide 8 by 2, you get 4. One's a plus, one's a minus. The square root of 49 is 7. Divide the 4 by 2, you get 2. Again, this is a difference of squares. Make sure you know perfect squares and perfect cubes. If you can recognize them, you'll know right away what kind they are. On the other side, here, we'll start with this one here. If you don't have your list of perfect cubes, you should write them down. 27 and 343 are on there. The cubed root of 27, if you look at your list, it's the third one on the list. If you look at 343, it has to be an odd number. It ends in odd. And it's the 7th number on the list. And again, if you look at these difference of cubes, or in this case, sum of cubes, practice writing these down. It's a plus b times a squared, opposite sign, minus ab plus b squared. If you have that, if you write that down, these aren't that complicated. So 3u plus, same sign, 7v times square the first term. 3u times 3u is 9u squared. Opposite sign. A times b. 3u times 7v is 21uv. Always positive. And then b squared. 7v times 7v, 49v squared. All right, so that should get you through this lesson. It's a pretty quick lesson if you follow that and write this down and study it. Make sure you submit this when you're done.